And we're jumping back in to talk about rectangles. So in the previous video, we talked about parallelograms and all of these properties of parallelograms. Well, the main property of a parallelogram is that both pairs of opposite sides are parallel. And if that's the case, then it's a parallelogram. So a rectangle is just a very specific type of parallelogram. So a rectangle follows all the parallelogram properties, plus a few more because it's a specific type. So make a little note that it follows the parallelogram properties, plus a few more because it's a specific type of parallelogram. Now, in a rectangle, all those rules from before were true. So for example, the opposite sides are congruent. So if this side is 5, then that side is 5. If this side is 6, then that side is 6. But in a in a rectangle, the specific rule is about the angles. So in a rectangle, all of your angles are 90 degrees. Now, 90 plus 90 equals 180, so they're still following that, like the opposite angles are congruent. If they're next to each other, they add up to 180. But the specific rule for a rectangle is that it's a parallelogram where all of your angles are congruent. So they're all going to equal 90 degrees, and that's the key part of a rectangle. Another key part of a rectangle is because you put all of these right angles in here, is that your diagonals will be congruent because they make right triangles. So the diagonals would be congruent. So for example, if I tell you this diagonal is 3 and 3, then the other one would be 3 and 3 as well. So like if this is 3, that has to be 3. That's a parallelogram property. But then all of these diagonals are going to be the same as well. So just taking a look, let's pretend that this side is 7, so then our other side would be 7. That's a parallelogram property. If this top is 24, then that bottom should be 24. That's a parallelogram property. And then I already know about these angles. So if I draw in my diagonals, well, I've made a right triangle. So I could do Pythagorean theorem and figure out that hypotenuse. So if I know this is 7 and that's 24, well, remember that we have those triples. So it's 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24. That's going to make this whole diagonal, this hypotenuse, 25. And I'm just like going with numbers off the top of my head, and we'll do some examples in a second. So if this whole thing is 25, then that means that this piece would be 12.5 and 12.5 because it's cut in half. It also means that this diagonal would be 12.5 and 12.5 because that should be the same as well. And the angle rules still apply. So like I had in that parallelogram where we talked about that last example, like if this is 60, then this one is 60, then that would make that 20, and that would make that one 20. It's the same thing here. So I'm just going to make up numbers. If this is 50, then this one would be 40, and then it would alternate. So over here, this one would be 50, and this one would be 40. And then because you have these isosceles triangles in here, this one would be 50, this one would be 40, and then it would alternate, and we'd have this pattern. So that would be 50, and that would be 40. So in a rectangle, so notice it goes 50, 40, 40, 50, 50, 40, 40, 50, and each corner should add up to 90. Now, because in a rectangle we have all of these triangles that we've created, and then I can find even these angles, because if I remember that a triangle adds up to 180, well, now I can take 50, and 50 is 100, subtract it from 180, and now I can find all of these angles. So what's kind of nice about these shapes is that they don't have to give you a lot of information, but we can use some prior knowledge to figure everything out. So let's take a look at just some very specific examples and see if we can figure out how to set up these problems. So taking a look at a rectangle, I need to remember that the diagonals are congruent and that all 4 corner angles equal 90 degrees. So back right here, all of these are going to equal 90 degrees. So all of those are going to equal 90. And the diagonals are congruent. And then I also need to remember that it follows parallelogram properties. So let's take it one problem at a time. So I have quadrilateral RSTU. I know that it's a rectangle with diagonals that intersect at point P. So I'm going to go ahead and sketch this out. And remember that we need to be very careful with drawing our rectangles because we're always going to start with any quadrilateral in this top left corner and work our way around. So this would be R, S, T, U. Okay, it said that it had diagonals, so I'm going to go ahead and put those diagonals in there. Intersect them at point P. And now I'm going to read what information they gave to me. So they talked about angle RSU. So if I trace an angle RSU, that corner right there, RSU is 3x minus 5. Okay, I also know that UST, so this one right here, so UST is 4x plus 4. Okay, and now I have to think, what do I know about a rectangle? So I don't have too many options with these problems. Either going to be that they part plus part, they add to a number, or they're going to be congruent and they're going to equal something. Well, I know that the full corner, remember in a rectangle, that the corners are all 90 degrees. So this corner right here is 90 degrees, which means that these two parts should add together to equal 90 since they're both in the corner. So part plus part equals 90. So I'm going to add these together. So 3x and 4x would make that 7x. Minus 5 plus 4 would make that 7x minus 1 equals 90 degrees. Because remember in the corner that they're just going to add up to 90 in a rectangle. So now I'm going to go ahead and add 1 to both sides. So 7x equals 91. And then I'm going to divide both sides by 7. So x would equal 13. Forgot the 1 there. So x would equal 13. Now, just because I know x, I can go plug that back in and I can find pretty much every other angle here. So if I go to plug it back in, 3 times 13 minus 5 would be 34 degrees. So this piece right here would be 34 degrees. Okay, which means if it follows a pattern, this would be 34 and then this one across would be 34. I can kind of look at the picture to guide me. Remember that these are all the same. So if this is 34 and that's 34, then this is 34. And this one is 34. I also like to think that rectangles are symmetrical. So if I fold it, it should all match up. And that makes it a little bit clearer to see where the 34 should go. Now if I plug into the other side, so 4 times 13 plus 4, that makes that this angle right there would be 56. So then all of these other angles would be 56. Because once again, I could fold it and then that alternating rule. Now, I could find these other angles because I have all these little triangles. I can add and subtract from 180 and find out even more information if we had to, but we don't. So let's take a look at another one. Let's take a look at another rectangle. And remember that we will have... Oh, lost my little thing. Remember that you'll have all of the rules, so you don't have to stress out about like which rule is which. You'll have a list of those rules. You'll have that paper. So I have quadrilateral ABCD is a rectangle with diagonals once again at point P. So remember that we start in the top left and work our way around. So this would be A, B, C, D. And I have two diagonals that intersect at point P. Okay, now A to C, so this whole diagonal right here, A to C, is 4x minus 13. And then this piece right here, DP, is x plus 7. Okay, well, in a rectangle, if I go back, the diagonals are congruent, which means that this diagonal should match this diagonal. But the problem is I'm missing this piece over here. But that's okay, I can find it, because remember that they bisect each other. That was the parallelogram rule. The diagonals bisect each other. So if I go back to this problem, if I know that this is x plus 7, well then this piece over here has to be x plus 7. And if the diagonals equal each other, then x plus 7 and x plus 7 tells me that full diagonal. And then that diagonal would equal this diagonal. So this is kind of like a part equals part problem, but I have a few more steps to go. So if this piece is x plus 7 and this piece is x plus 7, think, what would that make this full diagonal right here? And if I combine like terms, that would be 2x plus 14. And then those parts would equal each other. So 4x minus 13, one diagonal would equal the other diagonal, which is 2x plus 14. And now I'm going to solve. So I'm going to go ahead and put the letter on the left. So subtract 2x on both sides. So I have 2x minus 13 equals 14. Then I'm going to add 13. So now I have 2x equals 27. Divide by 2, and I get a decimal. I get 13.5, and that's totally fine. That's a-okay. I can always take that number and plug it back in just to double check it. So let's take a look at one more rectangle. If I have quadrilateral JKLM, so I'm going to give you a minute. Think, how would you draw this picture? I know it's a rectangle, but where would I put those letters? And you should get JKLM right there. So hopefully you got that. Okay, I have two diagonals that intersect at point P. Okay, they told me that LP, so this piece right here, is 3x plus 7. And I know that MK, I know that this full piece is 26. So this one's very, very similar to the last one, but because this is 26, I can easily cut 26 in half. If this full diagonal is 26, think, what would that make this piece and this piece? Remember, they're all the same, so that would equal 13. So if I don't want to double this piece, I could just, because this particular problem, I know the full thing's 26, so 26 divided by 2 is 13. So I could set this up and say that 3x plus 7 equals 13. My alternative is to say that 6x plus 14 equals 26. So instead of halving the 26, I could double this piece. And either way that you would solve it, you would get, so if I subtract 7, I get 3x equals 6, x equals 2. Or over here, I get that 6x equals 12, so x equals 2. Either way, I get the same answer. So that's it for rectangles. If you have trouble, remember to go back and look at those examples and look at your problems that you have right here. Like, look at the examples. Because it's got to be part equals part or part plus part equals something. And as long as you remember those rules, you should be in good shape. Good luck with your practice.